if you have A, B, C, D, and if you recall, the determinant of this is A times D minus B times C. That because to do an inverse, you had to do the determinant and then switch those values around, multiply it. Well, this is the determinant for a 2 by 2 matrix. And then they're going to give you a definition of a determinant there on page 167. If it's greater than n, your determinant is going to be, what you usually do is go along a row or along a column. And if you notice that they're doing that determinant A, and they're multiplying A11, and then they say the determinant of A11. What that means is they cross out the row and cross out the column, A11, and then that forms a determinant. And then what they do is they go minus A12. So you see they're going along a row, right? First, the subscript, the 1, and the first element in the subscript is the row, and the second element is the column. So they're going along a row, and then they're crossing. If you have A, B, C, D, E, F, G, H, I. A11 would be this thing right here, correct? That would be this. And then what they do is they cross out the row and the column, and this right here becomes that A11. So then they do the determinant of A11. Does that make sense? And then notice that this thing right here is the first, is then this value. And then they cross out the row and the column of that one, and then the determinant of A12 is going to be, A12 is going to be the DGFI. Do you see what it is? It's these two elements and these two elements. Do you follow what I'm? So they're just crossing off row and column, and then it's called a cofactor. The cofactor is what's left after that, and then you do the determinant of that. But now notice that the sign, see what the sign is doing? The sign here is positive, the sign here is negative. Then if you look at that next, if you were to do the next determinant, then you would go plus A13, the determinant of A13. The signs would change, alternate as you go across here. Does that make sense? The big A is after you cross the row and column out, what is left. And then if it's bigger than 3 by 3, then you have to do it again, right? Until you finally get it down to a 2 by 2. Does that make sense? Yeah. But then there'll be a better way of doing this, but I'm just trying to point out that, see, the signs alternate as you go across. But it's going to become clear as we go along. And if you see that what they're doing when they put the general thing there, they're saying that it's the sum, and they do a minus 1 to the 1 plus j a a1j, determinant of a1j. Now, if you look at this and you kind of generalize it, it's going to be it's going to become easy to evaluate, because you see, if you're going along this row here, this is a plus, this is a minus, this is a plus. Do you understand? See these things right here, correct? And then this, if you go down this column and you expand along the column, this would be minus and this would be plus. Understand what I'm saying? And what it's going to do is it's going to be, this thing is going to be the row plus the column. So the sign for the first column here is plus, because it's 1 plus 1. First row, second column, it's negative because it's a minus 1. See, it's this minus 1 to the 1 plus 2. First row, second column. Then this is going to be a minus 1 to the first row, third column. 1 plus 3 is plus. You see? So then you could actually say, well, right down here, if I'm expanding and I'm coming to this, what's the sign going to be? Well, it's going to be a minus 1 to it's the second row, the third column. So that'd be a negative. If for some reason you were expanding on this one. Does that make sense? It becomes really easy once you're doing it, because it's all these, depends on how you're expanding and where you're at. You kind of get an idea. You'll become clearer as we go along, but I just want that there is a system to the way it goes. Now you notice at the bottom of the page it's talking about cofactors, and that's, you see this thing right here, this capital A, that's the cofactor of the expansion. And that's what's left after you cross the row and column out that you're on. You got it? It's going to be easy. It'll be so easy you wonder how come it spend any time on it. So the theorem there on page 168 says the determinant of an n by n matrix A can be computed by a cofactor expansion across any row or down any column. Across any row, down any column. And then what it is, they're telling you the determinant, let's see, for an expansion across the ith row, then it's going to be, I1, I2, I3, I4 if it's across the row. If it's down a column, then you can do it any row or any column. And underneath there on 168, you see they're showing you what those signs are. See, like this would be the first row, first column, minus 1, first row, first column. Then it'd be minus 1, first row, second column. So you see this is a plus, and this is a minus. Then it's minus 1, first row, third column. So that's a plus, because it's a fourth. And when you go down here, this is a minus 1, second row, first column. So that's a negative. Right? So that's how that whole thing. So if you're expanding down the column, you would start out up here and go down the column, and you'd have your plus, minus, plus. If you were expanding on this column, then the first element would be minus, and if you're expanding down the second column, it'd be minus, plus, minus. And you'd find out what those were by doing a negative one row plus column. Okay? And then you would do cofactors, and you draw a line through the row and the column, and then whatever's left would be a determinant of that cofactor is what you do next. You get it? It's pretty easy. And then theorem 2, now see it says if A is a triangular matrix. So a triangular matrix is what? One in which it's zeros on either top or bottom half, right? So you have something down here, A, B, C, D, and then you have zeros up here. Did I do it right? And then you'd have some other values down here. And what it turns out, it's telling you that all you have to do is do the sum of the product of the entries. It says then determinant A is the product of the entries. It's the product of those entries. A times B times D. And you can prove it by doing cofactors. All right. Then it says compute the determinants. I'm on page 169. Compute the determinants in exercise 1 through 8 using a cofactor expansion across the first row. So what we would do is the determinant then of, and here's another thing. You don't have to put the determinant like that, because what you can do, if you write like absolute value, that's saying determinant. See, this is the same thing as doing this. Determinant of 0, 4, 1, 5, minus 3, 0, 2, minus 3, 1. The determinant of the matrix, if you do like an absolute value, that's just indicating you're doing a determinant of it. Okay. This is supposed to be positive? Okay. All right. So now they want to do an expansion along the first row. So what you do is you do 0 to the 1 plus 1. I mean, it's redundant, but then you do you cross out, I'm going to do this. Then the cofactor would be this, right? Crossing the first row out, the first column out, that would be the cofactor. And the two straight lines says the determinant of it, right? Then you do plus a minus 1. I don't know why I wrote this wrong. Pardon me. This is 0, and this is a minus 1 times to the power 1 plus 1. And this is a minus 1 to the power first row, second column, and then that number is 4, and then the cofactor is going to be 5, 0, 2, 1. And then it would be plus, the sign's going to be a -1, first row, third column of 1, cofactor, 5, -3, 2, 3. Does that make sense? Okay. So this 0 means that this whole thing goes out, right? So when I'm going to simplify this one here is going to make this a -4, right? And then the determinant there is 5 times 1 minus 0 times 2, right? And then that next one is plus, and then that's a -1 to the 1 plus 3 is 4, so that's still leaves it plus 1, and then it's 5 times 3 minus a -3 times 2. That makes sense? The determinant is always the product of these two minus the product of these two in a 2 by 2. Okay. So this is a -4 times 5, right? And this is a plus, and that's a 15 plus 6. 1 times that, right? So then we got a -45 plus 21. So we have what, a -24. If I did all my math right, that should be. I must have done math wrong someplace. 20. Okay. 45. That's pretty cool, isn't it? Would you like me to figure your stuff out for you? This is a -20. Yeah, 1. I didn't do my math right. Okay. So have I done it slow enough so, I mean, we can pretty much just whip along pretty good. So let's try number 4. And so they're saying straight lines is a determinant. 1, 2, 4, 3, 1, 1, 2, 4, 2. And they want it along the first row. So it's going to be a -1 to the 1 plus 1, 1 plus 1. And then it's that the value A11 is 1. And then it's the cofactor 1, 1, 4, 2 plus -1, first row, second column. 2 is A12, cofactor is 3, 1, 2, 2. And it's plus -1, first row, third column, 4, cofactor, 3, 1, 2, 4. So the first one's a positive, and it's just 2 minus 4, right? Second one is a -2, 6 minus 2. And the third one is a positive 4, 12 minus 2. So it's a minus 2. Then this is a minus 2 times 4, which is a minus 8. And then it's 4 times 10, which is plus 40. Now, did I do that right? 30? Okay, so you'll be able to just whip through these like zip, right? Now, let's look at that 9 through 14. It says compute the determinants in exercise 9 through 14 by cofactor expansion. At each step, choose a row or column that involves the least amount of computation. So, 10. One, let's see. Now what you want to do is you want to look for a row or column that has the most zeros in it. And that would be the second row, right? And the second row essentially is going to be, all you got to worry about is this one right here, right? So then you'd go a minus 1, and it's the second row plus third column. 3, and then the cofactor, when you cross those out, is going to be 1 minus 2, 2, 2 minus 4, 5, and 2, 0, 5. Now, have I written that right? Cofactor. Now what you want to do is you want to look at what would you want to do. So you kind of got a choice, don't you? You would do 2 operations coming down the second column or going across the third row. Correct? So now if I go across the third row, and this is going to be a negative 3, right? And then I'm going to go across the third row. So I'm going to go negative 1, third row, first column, 2, cofactor is a minus 2, that's the 3, minus 4, and 5. Then the 0, I'm just leaving out. Then I'm going to go plus a minus 1, third row, third column, 5, cofactor, 1 minus 2, 2 minus 4. Is that good? So then you're probably getting way ahead of me. Minus 3. Now, this is going to be minus 1 to the 3 plus 1 is 4, so that's a 2. Then I'm going to do the determinant, and that's going to be a minus 10 plus 12, right? Then it's plus 5, and then do the determinant, minus 4 plus 4, right? It's a minus 3 times 2 times 2, and that other thing is plus 0, right? 6. Did I do it right? Is that what you got? What's that? Positive 2. Oh, minus 3. Where did you come up with the other negative? Are you good? Is this good? Or did you, Ashley, did you come up with what I came up with? Okay. Same as I got. So what, this, this one here? Yeah. Oh, this was supposed to be a 2. Okay, well, then this would be a 2. Okay. I led you astray, Ashley. Okay, so that would change the sign, wouldn't it? It'd be a minus 8 here, wouldn't it? Yeah, plus 8 right there. Then that would make this one a minus 2 right here. Oh, you're so smart. That's because I couldn't read my writing. Sorry, Ashley. Okay. So let's try another one. Twelve. Now this one, if you look at that theorem 2, did you think about this? It says if A is a triangular matrix, is that a triangular matrix? And it says then determinant A is the product of the entries on the main diagonal. So we're going to use theorem 2. That'll give us the least amount of work, right? So it's 3 times 3 times a minus 3. Is that what it was? So 3 to the third, what is that, 27 times 2? Is that 54? So that really saves a lot of work. Okay, let's do a bigger one. 14. So you got two choices, don't you? Either the fourth row or the fifth column, whichever way you want to go first, right? And then once you do that, then you're going to have, the other one's going to show up as a, right? So which did you do? Okay, so Ashley, did you do anything yet? Did you do the column? We'll do the fifth column, because you see it's all zeros, and all we got to worry about is the -1, and this thing right here, that is the, let's see, third row, fifth column, and then it's 1, and then the cofactor is the 6, 3, 2, 4, 9, 0, 4, 1. And then we, -4. And then we don't do that one. This is going to be a 2, 0, 0, 0. And then a 4, 2, 3, 2. So it's a +1, 1. So then we're going to do this row, right? So it's going to be a -1, third row, first column. And that was not to confuse, that wasn't a minus. So it's a 2, and then its cofactor. 3, 2, 4, 0, -4, right? 1, and then it's 2, 3, 2. So now you got a choice, right? Either do first column or second row. That would be the easiest one. Which did you do? Column? Okay. So it's a +2. First column is a 3. Oops, I got to do my minuses. A minus. -1, 1 plus 1, 3, cofactor, 1, 2, and then I'm going to do plus a -1, and I'm doing this 2, and that's the third row, first column, 2, cofactor 2, 4, 3, 2. Okay. Okay. So I got a 2, and that's a times 3 times a minus 8 minus 3 plus 2, 4 minus 12. Is that what you were getting? 2 times 3 minus 11 plus, let's see, this had better be a bracket, plus 2, that was a 12, minus 8, 30, minus 33, minus 16. Am I coming close to what you guys are getting? 49. This one right here? Okay. Negative 4 and 1. So that would affect this one down here, right? Now then, that's 2 plus 16, huh? Is that what you got? It's 18. $36 plus 36. Okay. And this is 3. So now you got 6. Now I got what everyone else got. So now you guys can do them better than I can. Okay. The next set of problems, 15 through 18. It really only applies to an expansion of a 3 by 3 determinant. And you see those diagonal lines? It says add the downward diagonal products and subtract the upward products. And then compute the determinant. This trick does not generalize to in any reasonable way to 4 by 4 or larger. So we'll do it just because it's there, but it's just like a 3 by 3 is the only thing. Okay, 16. Zero, 3, 1, 4, so what we got to do here. that one. Oh, crap. Gonna do. So then you have to put a 0, put a 0 and a 3, and then you put this 4 here, then you put, I didn't run that out, 3 and a 4. And then they say these are the negatives and these are the positives. And it says add the downward diagonal products and subtract the upward products. So the downward products, this first one is 0, 0, 5, and whatever this number is, 1. That's a 0, right? There's no product there. It says add the downward diagonal products plus, maybe I should write this out. The first one is 0 times a minus 5 times 1 plus 3 times 0 times 3 plus 1 times 4 times 4. Then you subtract. And I'm going to start the 1 times 4 times 3 minus 4 times 0 times 0 minus 3 times a minus 5 times 1. So the top row, all we have is 16 here. And the bottom row, we're subtracting the 12. And then we're going to add 15, right? Is that right? So we come up with 19. Is that right? See, this is 0, this is 0, this is 16. This is minus 12, 0, and a plus 15, right? Which we're subtracting a positive 3 times a negative 5. I think so. Is that, everyone agree? No, they just say, see, they're just saying add the downward diagonal products and subtract the upward products. So you're taking the products and that's the way I read it. Okay. Well, what do you know? I did something right, you did it wrong. Score 1 for the teacher. That's the way I read it. Yeah. Okay. Now, it says, explore the effect of elementary row operations on the determinant of a matrix. So, these things, notice that all of these 19, 20, 21, 22, 23, and 24, do you see what they've done in 19 is they've interchanged two rows, right? Then in 20, which is what we're going to do, they've taken k times the second row and added it to the first row. And see, they're they're doing different operations on the thing. So 21, they've just multiplied k times the second row, so on. So just, I guess, for exploration, if you do the odd ones, you can kind of see what's happening. And then it'll make a theorem that we do later will make sense. So they say, explore the effects of elementary row operations on the determinant of the matrix. So they're saying, do the determinant of the matrix A, B, C, D. And that is A, D minus B, C. And then do the determinant of that A plus KC, B plus KD, CD. So this is going to be D times A plus KC, right? Minus C times B plus KD, which is AD plus KCD minus BC minus KBCD. Okay. So you see, this one and this one, if I've done my math right, go out, right? And then this is A, D minus B, C. And this one and this are the same. So it doesn't change the determinant. Not change determinant when multiply a constant times one row and add it to another. That's a lot of words, right? No change. How do we do that? So if we did 22, what would we expect? The determinants should be the same, shouldn't they? So we'll just check it out, 22. I'm just going to write determinant like this. 3, 2, 5, 4. That's going to be 12 minus 10 is 2, right? If we do the determinant, 3, 5 plus 3k, 2, 4 plus 2k. So this should be 3, 4 plus 2k minus 2 times 5 plus 3k. 12 minus 6k plus 6k minus 10 minus 6k. And sure enough, these comes out to be 2. Okay. Now notice on 24, what are they doing? They're multiplying one row by k, right? So term 1, 0, 1, minus 3, 4, minus 4, and then 2, minus 3, 1. First row, is that what you do? And so the first, it's going to be positive, right? When we do a minus 1 to the 1 plus 1, 1, and then the cofactor is 4. That was a minus 4, minus 3 and 1. And then it's plus a negative 1. First row, third column, 1 cofactor, minus 3, 4, 2 minus 3. So this is 4 plus 12 plus 9 minus 8. Oh yeah, thanks. This is 4 minus, because it's minus a plus. Okay, thank you. Minus 8 plus 1 equals a minus 7. Now, what are we doing? K, 0, K, minus 3, 4, and minus 4. And 2, minus 3, 1. So if we multiply the log that first row, we can see that these are going to be positive. So it's going to be K, right? And the cofactor is 4 minus 3, 1. And then it's plus K, and it's minus 3, 4, 2 minus 3. k times, what is it? 4, this was minus 12, you said, plus k 9 minus 8. You see, the k comes out, don't it? And we have a minus 8 plus 1. It's just going to multiply that thing by k. Okay, I'm going to quit. I got a terrible stomach ache. That's my